Article 220.13 addresses continuous loads in general, but it's crucial to distinguish it from Article 422.13, which specifically concerns water heaters. The original questioner suggested that they understood how 220.13 relates to 210.19, 215.2, and 230.42. However, there was confusion regarding water heaters and the specific requirements outlined in Article 422.13. So let's clarify the requirements. Article 422.13 pertains specifically to water heaters. It's important to note that the requirements for water heater branch circuit conductors have changed. It no longer requires 125% sizing for the branch circuit conductors, but does still require 125% sizing for the overcurrent protection. This means the water heater branch circuit must be sized at 125% of the water heater's nameplate amperage. To elaborate, the branch circuit conductors supplying a water heater must be rated to carry at least 125% of the water heater's rated current. This ensures the conductors can handle the continuous load without overheating or posing a safety hazard. This requirement is rooted in the fact that water heaters are considered continuous loads, meaning they operate for 3 hours or more at a time. Now let's address the applicability of demand factors. Article 220.3 allows for demand factors to be applied to certain household loads, but only those that are likely to operate simultaneously. The intent behind demand factors is to account for the fact that not all electrical loads in a dwelling unit will be operating at their maximum capacity at the same time. This allows for a reduction in the overall calculated load, which can result in smaller service and feeder conductors. However, water heaters are typically not considered a household load that will operate simultaneously with other household appliances, so the demand factor would not apply. Water heaters tend to operate independently, cycling on and off to maintain water temperature. They are not typically used at the same time as major appliances like ovens, clothes dryers, or air conditioners. Therefore, the full load of the water heater must be included in the calculation without any reduction due to demand factors. So, to summarize, firstly, the branch circuit conductors supplying a water heater must be sized at 125% of the water heater's nameplate amperage. Secondly, the overcurrent protection device protecting the branch circuit must also be sized at 125% of the water heater's nameplate amperage. Thirdly, demand factors cannot be applied to water heaters because they are not considered simultaneous household loads. The interpretation of the NEC articles plays a critical role in understanding these requirements to ensure water heaters are wired safely and in compliance with electrical codes. Now let's discuss an example. Imagine a water heater with a nameplate rating of 20 amps. To determine the minimum ampacity of the branch circuit conductors, you would multiply 20 amps by 1.25, resulting in 25 amps. Therefore, the branch circuit conductors must have an ampacity of at least 25 amps. You would then select an appropriate conductor size based on the ampacity rating found in NEC Table 310.16, considering the conductor's insulation type and the ambient temperature. Next, the overcurrent protection device, such as a circuit breaker, must also be sized at 125% of the water heater's nameplate amperage. In this case, 20 amps multiplied by 1.25 equals 25 amps. The next standard size overcurrent protection device is 30 amps. So, a 30 amp circuit breaker would be required to protect the water heater branch circuit. It is important to choose the correct size overcurrent protection device to protect the conductors and the water heater from overloads and short circuits. Using an overcurrent protection device that is too small can cause nuisance tripping, while using one that is too large can allow the conductors to overheat, potentially leading to a fire. Now, let's delve deeper into the relationship between Article 422.13 and other relevant NEC articles such as 210.19, 215.2, and 230.42. Article 210.19 covers the ampacity of branch circuit conductors and requires that they be sized to carry the non-continuous load plus 125% of the continuous load. Since water heaters are considered continuous loads, this requirement applies to the branch circuit conductors supplying the water heater. This means that the conductors must be sized to carry at least 125% of the water heater's nameplate amperage, as previously discussed. Article 215.2 addresses the ampacity of feeder conductors and requires that they be sized to carry the non-continuous load plus 125% of the continuous load. If the water heater is supplied by a feeder, the feeder conductors must be sized to carry at least 125% of the water heater's nameplate amperage, in addition to any other loads supplied by the feeder. The feeder conductors must be sized large enough to handle the total load, including the continuous load of the water heater. Article 230.42 covers the ampacity of service conductors and requires that they be sized to carry the non-continuous load plus 125% of the continuous load. If the water heater is supplied directly from the service conductors must be sized to carry at least 125% of the water heater's nameplate amperage, in addition to any other loads supplied by the service. The service conductors must be sized large enough to handle the total load, including the continuous load of the water heater. Now let's address the specific concern about the 75% demand factor mentioned in the original question. The demand factor in Article 220.3 only applies to household loads that are likely to operate simultaneously. Since water heaters are typically not considered a household load that will operate simultaneously with other household appliances, the demand factor would not apply. Therefore, the full load of the water heater must be included in the calculation without any reduction due to demand factors. It's important to understand the specific requirements for water heaters and to avoid applying demand factors inappropriately. To further clarify this point, consider a dwelling unit with 4 appliances. Firstly, a water heater, secondly, an electric range, thirdly, a clothes dryer, and fourthly, an air conditioner. The water heater is rated at 20 amps, the electric range is rated at 40 amps, the clothes dryer is rated at 30 amps, and the air conditioner is rated at 25 amps. To calculate the total load for the dwelling unit, you would need to consider the continuous and non-continuous loads separately. The water heater is a continuous load, so its full load of 20 amps must be included in the calculation at 125%. The electric range, clothes dryer, and air conditioner are not considered continuous loads, so their full loads can be included in the calculation without applying the 125% factor. The total continuous load is 20 amps multiplied by 1.25, which equals 25 amps. The total non-continuous load is 40 amps plus 30 amps plus 25 amps, which equals 95 amps. The total calculated load for the dwelling unit is 25 amps plus 95 amps, which equals 120 amps. In this example, the 75% demand factor would not apply to the water heater as it is not considered a simultaneous household load. The full load of the water heater must be included in the calculation without any reduction due to demand factors. It's essential to accurately assess the loads and apply the appropriate demand factors to ensure the electrical system is sized correctly. Now let's consider the impact of these requirements on the overall electrical system. Sizing the branch circuit conductors and overcurrent protection device at 125% of the water heater's nameplate amperage ensures the conductors can handle the continuous load without overheating or posing a safety hazard. This also helps to prevent nuisance tripping of the circuit breaker, which can be a common problem if the conductors are undersized. The feeder and service conductors must also be sized to carry at least 125% of the water heater's nameplate amperage if the water heater is supplied by a feeder or directly from the service. This ensures the entire electrical system is capable of handling the continuous load of the water heater, in addition to any other loads. By adhering to these requirements, you can ensure the electrical system is safe, reliable, and compliant with the NEC. It's important to consult the latest edition of the NEC and to seek guidance from a qualified electrician if you have any questions or concerns about water heater load calculations. Now let's explore some common mistakes to avoid when calculating water heater loads. Firstly, Failing to apply the 125% factor to the water heater's nameplate amperage is a common mistake. It's essential to remember that water heaters are considered continuous loads, so the branch circuit conductors and overcurrent protection device must be sized at 125% of the water heater's rated current. Secondly, incorrectly applying demand factors to water heaters is another common mistake. Water heaters are typically not considered a household load that will operate simultaneously with other household appliances, so the demand factor would not apply. The full load of the water heater must be included in the calculation, without any reduction due to demand factors. Thirdly, overlooking the requirements for feeder and service conductors is also a potential mistake. If the water heater is supplied by a feeder directly from the service, the feeder and service conductors must be sized to carry at least 125% of the water heater's nameplate amperage, in addition to any other loads. Failing to account for the water heater's load in the feeder and service calculations can result in an undersized electrical system. Fourthly, using the wrong conductor size or overcurrent protection device is another common mistake. The conductor size must be selected based on the ampacity rating found in NEC Table 310.16, considering the conductor's insulation type and the ambient temperature. The overcurrent protection device must be sized appropriately to protect the conductors and the water heater from overloads and short circuits. Fifthly, neglecting to consider voltage drop can also lead to problems. Voltage drop occurs when the voltage at the load is lower than the voltage at the source, due to the resistance of the conductors. Excessive voltage drop can cause the water heater to operate inefficiently or even fail. To minimize voltage drop, it's important to use the correct conductor size and to keep the conductor length as short as possible. Now let's shift our focus to the practical implications of these requirements for electrical contractors and installers. Firstly, electrical contractors and installers must be familiar with the specific requirements for water heaters and other continuous loads. This includes understanding the 125% sizing rule for branch circuit conductors and overcurrent protection devices, as well as the limitations on applying demand factors. Secondly, electrical contractors and installers must be able to accurately calculate water heater loads and select the appropriate conductor sizes and overcurrent protection devices. This requires a thorough understanding of the NEC and the ability to apply the relevant tables and calculations. Thirdly, electrical contractors and installers must ensure that all water heater installations are in compliance with the NEC and other applicable codes and standards. This includes verifying the conductor sizes, overcurrent protection devices, and wiring methods. Fourthly, electrical contractors and installers must provide clear and accurate documentation of all water heater installations, including load calculations, conductor sizes, and overcurrent protection device rating. This documentation can be helpful for future maintenance inspections and troubleshooting. Fifthly, electrical contractors and installers should stay up to date on the latest changes to the NEC and other applicable codes and standards. This can be achieved through continuing education courses, industry publications, and professional organizations. By staying informed and adhering to the latest requirements, electrical contractors and installers can ensure the safety, reliability, and compliance of water heater installations. Now let's address some frequently asked questions about water heater load calculations. Firstly, what happens if I don't size the branch circuit conductors and overcurrent protection device at 125% of the water heater's nameplate amperage? If you don't size the branch circuit conductors and overcurrent protection device at 125% of the water heater's nameplate amperage, the conductors may overheat, potentially leading to a fire. Additionally, the circuit breaker may trip frequently, causing inconvenience and disruption. Secondly, can I use a smaller conductor size if I use a higher rated overcurrent protection device? No, you cannot use a smaller conductor size if you use a higher rated overcurrent protection device. The conductor size must be selected based on the ampacity rating found in NEC Table 310.16, regardless of the overcurrent protection device rating. The overcurrent protection device is designed to protect the conductors from overloads and short circuits, so it must be sized appropriately for the conductor's ampacity. Thirdly, can I apply a demand factor to the water heater load if I have multiple water heaters in a dwelling unit? No, you cannot apply a demand factor to the water heater load even if you have multiple water heaters in a dwelling unit. Water heaters are typically not considered a household load that will operate simultaneously with other household appliances, so the demand factor would not apply. The full load of each water heater must be included in the calculation, without any reduction due to demand factors. Fourthly, what if the water heater's nameplate doesn't specify the amperage? If the water heater's nameplate doesn't specify the amperage, you can calculate it by dividing the wattage by the voltage. For example, if the water heater is rated at 4,500 watts and 240 volts, the amperage would be 4,500 watts divided by 240 volts, which equals 18.75 amps. You would then use this amperage to calculate the minimum ampacity of the branch circuit conductors and the overcurrent protection device rating. Fifthly, can I use aluminum conductors for a water heater branch circuit? Yes, you can use aluminum conductors for a water heater branch circuit, but you must ensure that the conductors are properly sized and terminated. Aluminum conductors have a lower ampacity than copper conductors, so you may need to use a larger conductor size to achieve the required ampacity. Additionally, aluminum conductors require special terminations that are designed to prevent corrosion and ensure a reliable connection. Now let's consider the role of technology in simplifying water heater load calculations. Several online calculators and software programs are available that can assist with water heater load calculations. These tools can automate the calculations and help to ensure accuracy. However, it's important to verify the results of these tools and to understand the underlying principles behind the calculations. Additionally, some smart water heaters are equipped with energy monitoring capabilities. These devices can track the water heater's energy consumption and provide insights into its operating patterns. This information can be helpful for optimizing water heater usage and reducing energy costs. In conclusion, water heater load calculations are an important aspect of electrical design and installation. By understanding the requirements of the NEC and applying the appropriate calculations, you can ensure the safety, reliability, and compliance of water heater installations. Remember to consult the latest edition of the NEC and to seek guidance from a qualified electrician if you have any questions or concerns.